This video is on best practices for hardening. In addition to physically securing network devices and opting to run secure protocols in favor of unsecured ones, an admin could also take following best practices steps to further harden the network. First, we have secure SNMP. Simple network management protocol collects a lot of data that could be of value to someone looking to compromise a network. Securing SNMP, utilizing SNMP version 3, protects the data more by moving from ports 161 and 162 to 10.161 and 10.162, and enables secure authentication and communication between SNMP manager and agent. Then we have router advertisement guard. With IPv6, routers will send out multicast messages to announce their availability and associated information. And this information is used by Neighbor Discovery Protocol (NDP) to detect what is available and configure accordingly. The problem is that the messages are unsecure, making them susceptible to spoofing. And to increase security, you can configure IPv6 router advertisement guard to protect the network against RA messages generated by unauthorized routers trying to join the network. Then we have port security. Port security works at layer 2 of OSI model and allows admins to configure switch ports so that only certain MAC addresses can use that port. This is a common feature on both Cisco's Catalyst as well as Juniper's EX series switches, and essentially differentiates so-called dumb switches from managed switches. Similarly, dynamic ARP inspection (DAI) works with these and other smart switches to protect ports from ARP spoofing. DAI, Dynamic ARP Inspection, is a security feature in switches that protects network against man-in-the-middle ARP spoofing attacks. It inspects address resolution protocol packets on the LAN and uses the information in the DHCP snooping table on the switch to validate the packets. Then we have control plane policing. Many routers and switches include control plane policing feature, which enables you to configure a quality of service filter to protect against DOS attacks. When enabled, the control plane can continue to forward packets despite an attack or abnormally heavy traffic load on a router or a switch. Then we have private VLANs, also known as port isolation. Creating a private VLAN is a method of restricting switch ports so that they can communicate only with a particular uplink. Private VLAN usually has numerous private ports and only one uplink, which is usually connected to a router or firewall. Then we have disable unneeded switch ports. Disabling unnecessary services increases security by removing doors that someone could use to enter the server. Similarly, IP ports that are not needed for devices also represent doors that could be used to sneak in. It is highly recommended that unused ports be disabled to increase security along with device ports. Same thing could also be applied to unneeded network services. It is recommended that a server be secure by removing services not in use. The easiest way for unauthorized individuals to access a device is to use default credentials that come in box. Changing default password is also recommended, and also applying complexity and length is recommended as well. It is a good thing to preach password security to users, but often admins are guilty of using too simplistic passwords on the network devices themselves. Then we have enable DHCP snooping. This provides a way for a switch to look at packets and drop DHCP traffic that it determines to be unacceptable based on a set of defined rules to prevent rogue DHCP servers from offering IP addresses to clients. Then we have change default VLAN. On switches, the native VLAN is the only VLAN that is not tagged in a trunk. And this means that native VLAN frames are transmitted unchanged. And by default, the native VLAN is port 1, and that default represents a weakness in that it is something known about your network that an attacker could use. And to strengthen your security, you can change the native VLAN to another port. Then we have patch and firmware management. There's a reason why each firmware update is written. Sometimes it is to optimize the device or make it more compatible with other devices. Other times it is to fix security issues and or head off identified problems. You need to make sure you properly test the patch and firmware and update as required. Test each release on a lab machine to make sure you're not adding to network woes, and then keep your software current to harden it. Then we have access control list. This enables devices in your network to ignore requests from specified users or system or to grant them access to certain network capabilities. Then we have role-based access. The use of roles to control access can be an effective means of developing and enforcing enterprise-specific security policies and for streamlining the security management process. Roles should receive only the privilege level necessary to do the job associated with that role. The general security principle is known as least privilege concept. When people are hired in an organization, their roles are clearly defined. Network admins create a user account for a new employee and places that user account in a group with people who have the same role in that organization. Then we have firewall rules. Firewall rules are used to dictate what traffic can pass between the firewall and the internal network. 3 possible actions can be taken based on the rules criteria. Block the connection, which is explicit deny, accept the connection, or allow the connection if the conditions are met, such as it being secure. An implicit deny only denies the permission until the user or group is allowed to perform the permission. Explicit deny is when admin has selected the deny option for a permission for a user or group.